Hello and welcome everyone to this edition of our global webinar series. Today you will learn about automotive applications, onboard charging systems. My name is Leslie Bartels and I'm on the marketing team here at Chemet, a YAGEO company, and I will moderate the webinar today. We're very pleased that you could find the time to join us for this webinar. The presenter today is Alexander Nebel, our field application engineer. So with this information, I'm going to hand it over to Alex. Hello, Alex. Thank you for your time today. Please tell us a little bit about yourself before you begin the webinar.
Yes, thank you, Leslie. My name is Alexander Nebel. I'm located in Germany, in Europe, and I am responsible field application engineer for our automotive customers. And today I'm going to teach you something about our onboard charging, or not our onboard charging technology, but the passive components that might fit into an onboard charging technology. And maybe you have seen this presentation before, but today we have some news because today we are covering the full YAGEO Group components. And this will mean I can offer you 3 times the products you have seen in the past. So let's start firstly with the agenda. And this is what we are covering today. So the first part is we're going to look into the onboard charging technology, the application and the block diagram. The second part, which is the biggest part, is the product solutions that we can offer. So the requirements and also our ACQ 200 qualified product overview. And finally, I will come to a short conclusion. So, but now let's start directly with the onboard charging technology. So the application. And here in the picture, we can see how an onboard charger looks like and where it is located. And this is actually the one which is used in an electric vehicle or hybrid vehicle to charge the traction battery. And this one is described in the material which belows the which converts the AC input from the grid to the DC in the car. So we are going somewhere in the high voltage range, so what we call high voltage. Now some facts about the onboard charging technology. So here we can see a car and the different possibilities how to charge your car. So the one possibility is to use a DC charging station, which could be a high-speed charging station. Also, we have the possibility to have a wireless power charging, which needs no cable, or the AC charging from what you have at home. Which means here you need exactly the onboard charger to transfer the voltage into the battery pack. Typical onboard charging power levels are printed on the right side. So depending if you have 1-phase or 3-phase and what is your input voltage, you can have 120 volt, 230 volt, and depending on the ampere you are offering, you have different power levels. And for sure, the higher the power level is, the smaller we can charge our car. The typical DC charging level is somehow 400 kilowatts. Just a comparison, which is not 100% perfect calculation, but if you take a smartphone charger, which is somewhere around 10 watts, you can imagine just to reach this one phase here, the 3.3 kilowatt, you need somehow 330 to 350 smartphone chargers to cover the same rate which you have on a normal EV charger. So also an interesting number to know is the charging duration. So we can see the difference in the power level here. DC charging is really fast, somehow 40 minutes, 30 to 40 minutes to reach nearly 80% of the full battery power. If you take the AC power grid at home, it lasts 6 to 8 hours, depending on where you are on the right side. But now let's go a little bit more deeper in the technology itself. And we can split the onboard charging technology up into 4 parts. So the first part is the left one is the EMI filter. So somewhere we have an input, 2-phase, 3-phase, whatever, and we need to have an input filter with capacitors, inductors, and we will go deeper in the first part and in my next presentation part. The second one is the PFC stage. The PFC stage is here in the middle. Then we go into the next stage, which is the resonant stage or DC-DC stage. And here we can also talk about the LLC resonance stage if you have an integrated transformer. This depends finally on the solution you are looking for. And there are already technologies without using the transformer. And finally, at the output, we do have the output filter on the right side, which is here marked in red. So this was really the introduction, and now I want to go step by step from EMI filter, from the input side until the output filter, and show you which components might fit into your application, and also discuss about the unique selling points and the pros and cons we are having here. So let's start with the first step, which is the EMI filter. And I've listed some components, and here you already see from the capacitor world, we do need X capacitors and Y capacitors, and usually we are using film capacitors here. Why do we use film capacitors? Because they have self-healing, which means we have fail-open mode. And the film technology for this is the best we can offer. For sure, we do also have ceramic capacitors, which are X certified. There are some things to consider. If this is interesting, please let us know, we can offer them. Also, from the inductor side, we can offer common mode chokes, either two-phase or three-phase filtering. And if it's a bidirectional system, which is not, let's say, the most used one, then we can also think about current sensing. This might be an option, but it's no must-have. So let's go step by step into each of these single parts and look at the components we can offer. As X capacitors, we do offer from YAGEO side the R52 or R47 series. So you don't need to look at the part numbering, but we can think about why is film capacitor so good. And as I mentioned before, we do have the self-healing capability, which is quite good. And the reason for this is we are using a single metallized polypropylene film for nearly all our film capacitors. And this means if we have a failure inside the component, it's always open. And this is either for class 2 or class X2 or class X1, and also what we see on the next page for the Y capacitors. Well, we do have a temperature range, or do offer up to 110 degrees, which is quite okay. Maybe if you need more, we do have also a solution, but this is the standard what we can offer for film capacitor technology. If we are looking into class Y capacitors, we have the same requirements, which mean the main requirements is our self-healing capability, also temperature range, the more the better. But also, if you might think about another technology, maybe to save space, we can think about our paper technology. Paper technology is also available in class Y2 dielectric application, and also has the same self-healing capability like the metallized polypropylene film. But this component is an SMD component and might fit better into your application. But on this side, please consider that we only have a limitation up to 100 degrees due to its technology. Now let's go a little bit to the next part, and we have talked about the common mode chokes. And here we do offer several different solutions. The common mode choke is usually this what comes after the X and the Y capacitor. This is the next stage. And we do have common mode chokes for either two-phase or three-phase sintering. And here you can really check if you need SMT or THT platforms, and also the maximum current. So depending on if you're going up to 40 amps or if you need much more, then we also can think about a customized solution for high current. So what we see here, and you can see the pulse name, this is the pulse part from YAGEO, as pulse also belongs to YAGEO. And on our next page, these components are coming from CAMT. So what we see here is also solutions for common mode chokes with ACQ200. Also here we have different constructions. This one is rated up to 50 amps, but also we can offer solutions up to 150 degrees. The dual mode choke, which we have here on the left side, is some special design, which has also differential mode filtering. So we do have both common mode and differential mode in one item. And this is just because we are using this oval shape. Now, I mentioned before that we can also think about current sensing, and the current sensor, what we have here is just the current sensing, which is, let's say, partially on the board. So it is connected to the board on the bottom, but the cable where you want to measure the current, this has to be put through this hole. So we do have a PCB mounting, but finally the cable is put here. There are some specials about this component. Please let us know if this is interesting for you. We do have also customized design or maybe a full PCB design. Also, we can think about current sense magnetics. And current sense magnetics, we have different solutions depending on the requirements. Mainly, we are looking for the voltage. So if it's 500 volts or much more, and this is just the main difference between those items we can see here on the bottom. And also, we can think about SMT or THT solutions. Now, let's move to the next stage, which is the PFC stage. And in the PFC stage, we can offer various items. So we can talk about current sense resistors, the current sense magnetics we have seen on the last page. Also, we can think about PFC inductors, and the ceramic capacitors get interesting also when we think about DC link capacitor. And DC link capacitors, we have something out of each family: ceramic, film, or electrolytic. Well, let's go a little bit more deeper into this series. So first start with the current sense resistors, and you might have seen this picture before. The main point about this is we can offer very small case sizes down to 0.05 up to 2520, depending on which power rate you need. And if you need up to 36 watts, this is also possible. And due to the simple construction, operating temperature up to 275 are available, which is mainly not needed here in this stage. Next one is our current sense magnetics, and we have seen this picture before, and you can see here in the picture on the top right our typical application circuit where this might fit. So here you can have the current sense magnetic, which is actually working as a transformer. And then we have also our high power PFC boost inductors, and the boost inductor of the PFC stage is here at the top. You can see it in the yellow section. And there are some critical specs, so we can offer always customized solutions. We can minimize the core losses, also the inductance at peak current, and we do offer very good thermal performance. You can see here 3 different pictures of different solutions for different power classes. So either if it's 2 kV or 11 kV or 6.6 kV, there are different solutions also in the structure, how you can put this to the board. So if there is something special needed, something customized, we can help you. Ask our FAE or your local sales representative from YAGEO, and we can help you to design a customized design. Our low power isolation transformers as gate drive transformers, well, this looks similar to what we have seen before. There are some things to be considered, so especially the creepage and clearance distance. And for sure, also here we can think about a customized design. We really recommend to use an existing model, but if there are some critical points, please let us know. So for the DC link capacitors, I mentioned just before that we can offer 3 different technologies. So first start with a ceramic capacitor. And this one is our KC link. KC link is just the name of the series. It's a DC link capacitor, which is really made for or a ceramic capacitor, which is really made for DC link application. We are using here class 1 dielectric, which means this is COG. And therefore, we have no capacitance shift with voltage. That means this is a very stable capacitance range. Also, we can offer high current capability up to 15 amps. And the one thing which is really perfect is the high frequency operation. And this is the main advantage of the ceramic technology in comparison to all others we can have. We are going here much higher than 10 megahertz. And for sure, the operating temperature, which is going up to 150 degrees, is also something which is outstanding for the ceramic technology. Well, sometimes it's not needed to use this special item. And for some customers, it might also be interesting, or for some applications, to use standard ceramic capacitor. And from YAGEO, we do offer a wide range of MLCCs with ACQ200 certification in a wide voltage range up to 250 volt DC. Also case size is starting at 04 or 2 and going up to 2220. And depending on what you need, and for DC link, this might be an option to use either X7R or COG dielectric. All components are available with flexible termination or soft termination. This is actually the same. I know customers or competitors are using also sometimes the name soft termination. It's actually the same technology. And here we can offer up to 5 mm flex performance. No need to discuss about PPAP. We can offer anything you need. And also, if this is a requirement, we have the Volkswagen 8088 approved items available as well. It might be that not one ceramic capacitor is enough. In this case, it might be an option to use several ceramic capacitors in parallel or in series to achieve more capacitance or more voltage. But well, if you have some space constraints, then let's go into the connect technology. And what you here see is actually what we offer. This is a stacked item, but without metal frame. And the metal frame is usually what is really expensive. So by saving the metal frame and still connecting them, so they are not, it's not single items, they are stacked together and will not fall apart with our transient liquid phase sintering method. And this means we can have more than one item, 3 or 4 is possible, in parallel without using more board space. So by using the same pad, you can have 3 times or 4 times the capacitance in parallel. We cannot stack all components at the moment. We do have a special series, but please consider the connect technology is not a single part. It's just connecting existing parts what we have. And therefore, the operating temperature is depending on if you're using COG, X7R or whatever. And the same is also for the high ripple current capability. If you're using other items, you might have a higher ripple current capability. But ceramic capacitors is not all what we can offer for DC link capacitors. We do have film capacitors, and as we have seen before, they are as well with metallized single metallized polypropylene. Our C4AQ series, they always start with C4AQ, but we do have a special with a C4AQ-M and C4AQ-P. Very simple. The M stands for miniaturized. So this one is smaller than the standard item as we are using thinner film. And this means you have more capacitance in the same size, or you have a smaller item in the same capacitance range. And this is a real advantage. And I haven't seen this somewhere else. So here, this is a really unique selling point. The P is our high performance version, which means we have a higher testing for this component. Now, if this is still not enough for you, we can also offer our C4AU and C4AK series. And when it comes to the C4AU series, sorry, this one is for harsh environments and is tested, extended life test at THB. The C4AK series, this one is at higher temperature. So we do here have a temperature up to 135. So all belong to the same family and are the same technology. It's our film technology, but depending on what you need, if you're more looking about size or if you're more looking on temperature, we can offer you the best solution. We have seen it also in the picture before. We do have a low profile version. That means the winding is just not vertical, but horizontal. That means the item is thinner on the board. You have height problems, but you use more PCB space. Actually, the black box is the same size, but the one time it's horizontal on the board and one time it's vertical. Both is possible. Just ask us. And last but not least, for the DC link solution, we do have an electrolytic capacitor, which is a nice technology because we can offer high capacitance ranges, also high voltage ranges. We are somehow limited in the temperature, and we do have 2 series, the one ALA7D, which is up to 85 degrees, and the same series, which is called ALA8D, which goes up to 105 degrees. But please consider, the lower the temperature, the longer the lifetime for electrolytic capacitors. So if you are considering the temperature in your application, maybe this is you should look for another technology. Now coming to the third stage, which is our resonance stage. And again, we can think about ceramic capacitors or film capacitors. We are looking again into current sense magnetics. We can jump over this, but then also we have to talk about high power magnetics, resonance stage transformers, and also an isolation gauge drive transformer. Ceramic capacitors, I did mention them before. So this slide is nearly the same what we have seen a few slides ago. For the resonant or snubber capacitor, we do really recommend to use COG, and X7R might not fit perfectly. But for COG, we can deliver up to 470 nanofarad. And also the same situation here. If this is not enough for you, we still don't forget our Connect technology to reach 3 times the capacitance value by just putting 3 times in a stack. Now let's look for the resonant or snubber capacitor into our film solutions. And again, here we have our single metallized polypropylene film, which is really space saving. Also the same advantages for the same harsh environments designs. For sure, this is a perfect item. We do offer 2 different solutions, R75 or H, R75H, and the main difference is the temperature. If the 105 degrees are not enough, take the R75H, and this one is up to 125 degrees. So here we have really a good solution for the resonant or snubber capacitor. But we do offer also our R76 or R76H series. This one is nearly similar, but we have here a double metallized polypropylene film, which means this one is on both sides metallized. So and here we can have higher values for capacitance. The rest of the values seem similar. Also, what the temperature range. Again, the temperature range for the H series goes up to 125 degrees. And like we have seen before, we do offer a low profile version. Current sense magnetics, we have seen this picture before, so no need to talk about this again. So we can go further and we talk about the high power transformers and resonant inductor. And as I told here, the transformer is on this stage, so just at the end of our resonant stage. So we know that most of the time when it comes to transformers, we are talking about customized solution, and for sure we can offer different customized solution, but as well we do have some standard items. Again, we need to look at the isolation requirements for your application and also about the thermal performance and for sure the safety insulation requirements, either if it's functional, basic or reinforced. And again, safety creep-pins clearance distance needs to be considered, and this depends on your design of the pins or whatever you need. So please let us know if you need something special designed especially for you. And then we have our low power isolation transformers, and this slide we have also seen before. We have different series depending on the voltage range, either if it's 2.5 kilovolt, 5 kilovolt, 4 kilovolt, and if it's the functional, reinforced, or the basic insulation requirements. So finally, we are coming to the last stage of our onboard charger, and the last stage is the output filter. Well, output filter, it's clear we can think about an inductor, we can think about capacitor, and we can think about current sense resistors. Now let's have a look at each technology, starting at high power inductors. And high power inductors, we can offer various solutions. And you see on the products here, we have pulse solution as example. So there are different solutions. This technology might seem more known, but also we can have special items. The main point on this inductor is for sure the current values. So you can see we can go up to 180, 68 or 56 items. These are really high current items. And you can see on the connection, it's not just a pin, it's really a flat wire, which makes it possible to carry that high current. Also, we can minimize AC losses depending on our design or on the used material. Well, we have seen this picture before. Also good for an output filter, our C4AQ series. Don't need to cover that again, but everything we have seen before, either if it's our C4AQ or, I hope you still remember, C4AQM, which is miniaturized, might fit into your solution. And for harsh environments or high temperature, C4AU or C4AK. Let's jump over to the series which might fit a little bit more into an output filter, which is the filter capacitor in ceramic technology. So again, we are looking in X7R, maybe COG, but this is a technology which might be from price, size, or technology side the best solution for the output filter. And here we are at the summary. So I'm good in the time I can see, and I really do like this picture, because if you count now the solution we have talked about today in the last, let's say, 25 minutes, you can see there are more than 20 different items we can offer from YAGEO side for an onboard charging system. So we can cover the whole passive component section. You don't need any other vendor besides YAGEO, which is very good. I think that's an advantage. And either if you need, if you are looking more on size, if you're looking more on temperature or voltage, we do offer different solutions. There's not one single solution. It's not always film. It's not always a ceramic, or if it's metal composite, we do offer different solutions. When it really comes to your application, I'm quite sure we need to discuss a little bit more deeper. And in this case, please contact your local FAE, please contact your local sales representative, and then we can find the best solution for your application. And I hope this is something I could show you today in the last 30 minutes. And now I'm open for questions.
Right, thank you, Alex. So we do have a question. It's a general film capacitor question. Are all YAGEO Chemet film capacitors of wound construction, or are any series offered in a stacked construction?
Yes, for sure. We do have also a stacked construction. The wound construction is the most common used in these applications we have seen here before. But yes, we do have a stacked possibility. And also we do offer SMD versions. What I showed today was really the common used series. But if you need something special, stacked PCB solution, please let us know. We can offer something, yes.
Great, we do have a few more minutes if anyone has any additional questions. All right, we have a question. Are tantalum capacitors used in OBC? Why or why not?
Yes, that's a perfect question, because really that was the one series I did not cover today. From my experience, it's so far it is not used that much. You might think about this at the output filter. You might consider this instead of using the MLCC. On any other place like the DC link, it cannot fit. We cannot think about tantalum capacitors, but maybe at the output filter side. So what we have seen at the last stage, we have presented again the MLCC. This might be an option, but to be honest, out of my experience and in my projects where I'm involved, I have not seen the tantalum capacitors so far. But maybe this changes.
So thank you so much for attending today's webinar. And thank you so much, Alex. That was really informative. As I mentioned before, please complete the post-webinar survey to help us continue to improve our webinar programming. And have a great day. And we hope to see you at our next webinar.
Thank you, Leslie. Thank you to the audience.